Hey there. Ready to dive into something truly mind-blowing? We're talking robot audition today.
Robot audition.
And no, it's not about robots like belting out their favorite tunes on stage.
No, not at all.
It's about giving them the power to really understand the symphony of sounds all around them.
Exactly. It's like, imagine a world where robots don't just hear, but they actually comprehend the soundscape, just like you and I do.
That sounds straight out of science fiction.
It kind of does.
But from what I've been reading in all these research papers, it's becoming a reality.
Oh, yeah, definitely.
So let's break this down. What exactly is robot audition?
Well, think of it as giving robots a more human-like way of hearing. It's not just about capturing sounds with microphones, but processing and interpreting those sounds in these complex, real-world environments. Just like you can filter out the noise of traffic to focus on a conversation, robots with audition capabilities can isolate and understand specific sounds, even amidst a whole bunch of noise.
Okay, so it's about equipping robots with the ability to analyze and understand sounds, not just record them. That's fascinating.
Right. And this understanding goes beyond simply identifying the source of a sound. It goes into higher-level processing, enabling robots to understand the meaning and context of sounds.
Okay, so give me an example.
For instance, a robot with robot audition could not only hear a siren, but recognize it as an emergency vehicle approaching and then react accordingly.
Now that's what I call intelligent listening. It sounds like robot audition takes inspiration from how we humans hear, but takes it to a whole new level.
Yeah, you hit the nail on the head. Early research in this field was heavily influenced by the study of human hearing. Back in the 1990s, scientists were fascinated by how our brains can process multiple sound sources simultaneously and make sense of the auditory chaos around us. That field of study is called computational auditory scene analysis, or TASA for short, and it laid the groundwork for many of the techniques that we use in robot audition today.
It's amazing to me how understanding our own biology can pave the way for such groundbreaking technology. So what are the key ingredients that make robot audition so special?
There are four main requirements that really set robot audition apart. The first is the ability to understand general sound. In the real world, sounds rarely exist in isolation. What a robot hears is usually a mixture of sounds from various sources all blended together. It needs to be able to untangle that mess and identify individual sound sources.
So it's got to be able to pick out the individual instruments in an orchestra.
Exactly. Just like a conductor separating the melodies of different instruments in an orchestra. What's the second requirement?
I'm intrigued. What's next?
The second is active audition. Unlike a stationary microphone, a robot can move around to improve its hearing. Think about how you might tilt your head or lean closer to someone to hear them better in a noisy environment. Robots with active audition can do the same, adjusting their position to reduce noise and get a clearer sound.
Gotcha. So it's not just about passively listening. It's about actively engaging with the soundscape. Starting to see how this could lead to some really impressive capabilities.
Absolutely. That brings us to the third requirement, multimodal integration. This is all about combining audio data with information from other senses, like vision.
Multimodal integration.
Okay, so if a robot sees a person speaking, it can use that visual cue to help focus its attention on that particular sound source.
Kind of like putting together pieces of a puzzle to get a fuller picture of what's happening around it.
Yes, exactly. And that brings us to the fourth and perhaps most crucial requirement, the ability to process information in real time.
Real-time processing. I can see how that would be important.
Right. For a robot to interact with humans seamlessly, it needs to be able to analyze and respond to sounds instantaneously, not after minutes of processing. Imagine having a conversation with someone who took a long pause to process every word you said. It wouldn't be a very natural interaction.
You're right. It needs to be able to keep up with the flow of conversation. Now, I'm curious to know how robot audition has evolved over the years. Where did it all begin?
Well, early research in the early 2000s focused on what's called the binaural approach. This essentially mimics human hearing by using two microphones to capture the subtle differences in sound arrival time and intensity at each microphone. This helps determine the direction a sound is coming from, just like our 2 ears allow us to pinpoint the location of a sound.
So they started by taking inspiration from our own biology. Makes sense. But I imagine there were limitations with just using two microphones.
Oh, you're absolutely right. Researchers quickly realized that to create truly robust robot audition systems, they needed to go beyond the binaural approach. That led to the development of microphone array processing in the mid-2000s, which involves using multiple microphones strategically placed to capture a richer and more accurate soundscape.
So more ears mean better hearing for robots, too.
Exactly. This shift to microphone arrays was a game changer. It allowed robots to understand multiple people speaking at once, filter out noise more effectively, and even pinpoint the location of sound sources with remarkable accuracy.
Okay, that's impressive. Speaking of breakthroughs, I understand there was a particular development that really propelled the field of robot audition forward, a software toolkit called HARK. Can you tell me more about that?
Absolutely. HARK emerged in 2008 as an open source toolkit, making it easier for researchers and developers to build and experiment with robot audition systems. You see, prior to this building, these systems required specialized hardware and expertise, limiting the number of people who could contribute to the field. But with HARK, all that changed.
It's amazing how these open source projects can really democratize technology and spark innovation.
Yeah. HARK provided a user-friendly interface and real-time processing capabilities, making it accessible to a much wider audience. It even came with a standard 8-channel circular microphone array design, further lowering the barrier to entry for those who wanted to explore the possibilities of robot audition.
Wait, so they provided the hardware design too?
They did.
That's incredible. It's no wonder HARK had such a significant impact on the field.
It was a crucial step toward making robot audition more practical and widely applicable. And with Aaron paving the way, the field just exploded with new research and applications.
So with Aaron making things easier, let's talk about some of those real-world applications. Where is this technology being used today?
One area is information and communications technology, or ICT. Imagine interactive tablets equipped with microphone arrays that can understand and respond to voice commands from multiple users, even in noisy environments.
That would definitely make for a more seamless and intuitive user experience, especially for collaborative tasks. Are there any other areas where robot audition is making a difference?
Another exciting application is in the automotive industry. Picture a world where your car can understand commands from multiple passengers, adjust settings based on who's speaking, and even provide personalized entertainment options.
Wow, so robot audition could make the driving experience safer, more convenient, and more enjoyable for everyone.
Exactly.
But what about applications beyond our everyday lives? I've heard that robot audition is being used in some pretty incredible ways to save lives.
You're right. Search and rescue is one area where robot audition is having a profound impact. Drones equipped with this technology can locate survivors in disaster zones by detecting their voices or other sounds, even in challenging conditions like darkness or rubble.
That's remarkable. I can only imagine how crucial this technology could be in those critical situations. Seems like robot audition is stepping up to the challenge where other sensing technologies might fall short.
Absolutely. And we're only scratching the surface of what's possible. Researchers are constantly pushing the boundaries, developing new algorithms and applications that are changing the way we think about sound and its role in robotics.
This has been a fascinating dive into the world of robot audition so far. From its humble beginnings to its life-saving applications, it's clear that this technology has the potential to transform our world in profound ways. But before we get ahead of ourselves, let's take a closer look at one particularly remarkable application, drone audition.
Yes, drone audition is a fantastic example of how this technology is being used to address real-world challenges and make a positive impact.
I'm all ears. Let's hear it.
So picture this: a disaster zone where every second counts, roads are blocked. Visibility is poor, and traditional search methods are just too slow and limited.
Yeah, it's a situation where those traditional methods can be really challenging and sometimes even dangerous for the rescue teams.
Exactly. That's where drone audition comes in. By equipping drones with microphone arrays and those advanced sound processing algorithms, we can dramatically improve our ability to find survivors quickly and efficiently.
It's like giving rescuers an extra set of ears in the sky. But drones are notoriously noisy. How can they possibly hear anything over the roar of their own propellers? It seems counterintuitive to use sound to search when the search tool itself is creating so much noise.
That's a really great question, and it's one of the biggest challenges in drone audition. But remember that open source software we talked about earlier, HARK? Well, it played a key role in overcoming this obstacle.
Oh, right. HARK. It seems like that software is popping up everywhere in robot audition. It's amazing how one piece of software has had such a ripple effect.
It really has it. Researchers used HARK to develop noise reduction techniques that can filter out the drone's own sounds, allowing it to focus on other sounds in the environment.
So it's like giving the drone noise-canceling headphones, only way more sophisticated. That's impressive. But how effective is this in real-world situations? I mean, disaster zones are chaotic environments with all sorts of sounds competing for attention.
You're right. But a project in Japan called the Tough Robotics Challenge put drone audition to the test. And the results were remarkable. They were able to detect human voices from a distance of 12 to 15 meters, even in environments with a signal-to-noise ratio of negative 15 decibels.
Hold on, negative 15 decibels. For those of us who aren't audio engineers, can you explain what that means?
Sure, decibels measure the intensity of sound. A negative signal-to-noise ratio means the background noise is actually louder than the signal they're trying to detect. Think of trying to hear a whisper in a noisy restaurant. That's roughly what a negative 15 dB signal-to-noise ratio would feel like.
Wow. So the drone is picking up those faint human sounds and all that noise? That's incredible.
It is, and that's not all. These drones can also pinpoint the location of a sound source in 3 dimensions, even if it's hidden under rubble.
Okay, that's next level stuff. It's like having a sonic radar that can see through walls. How did that even work?
It's achieved by combining the audio data with a 3D map of the area. By analyzing the subtle differences in how the sound waves reach the microphone array, the drone can calculate the precise location of the sound source in 3D space.
So the drone can actually guide rescuers directly to the survivor's location, even if they're completely hidden. That's incredible.
Exactly. And this ability to see with sound is especially valuable in these kinds of situations. Unlike visual sensors, drone audition can work in complete darkness, or even through smoke and dust. It doesn't rely on survivors having a light source or making a visual signal. Their voice, a cry for help, or even the sound of tapping is enough for the drone to find them.
That's a game changer. It seems like drone audition offers a unique set of capabilities that complement other search and rescue technologies. For example, we often hear about thermal imaging being used to locate people based on their body heat.
Right, thermal imaging is a great tool, but it has its limitations. It can be thrown off by other heat sources in the environment, which leads to false positives. Drone audition is much more specific in identifying human sounds, which makes it a more reliable tool for locating survivors.
It sounds like drone audition is really carving out a niche for itself in search and rescue, offering a level of precision and reliability that's hard to beat. And what's even more exciting is that research in this area is constantly pushing the boundaries of what's possible.
Yes, and one particularly cutting-edge area of research that I find fascinating is audio-visual scene reconstruction.
Audio-visual scene reconstruction. That sounds intriguing. We've talked about how robots can use vision to improve their hearing, but are you saying they can also use hearing to improve their vision?
Exactly. This research is still in its early stages, but the results are already very promising. Imagine a robot that can not only see a scene, but also use sound to fill in the missing pieces, creating a richer and more complete understanding of its surroundings.
That's mind-blowing. So what are some of the limitations of traditional visual scene reconstruction that audio can help to overcome?
Well, traditional 3D scene reconstruction techniques rely solely on visual information, and they often struggle with dynamic scenes where objects are moving. They also have a hard time detecting transparent objects like glass walls because these objects don't reflect light in the same way as opaque objects.
Okay, so how does audio-visual scene reconstruction help to solve these problems?
Let's take the example of a fan that's rotating. If you try to reconstruct a 3D model of the scene using only images, the rotating blades will appear blurry and distorted. But if you incorporate sound information, you can pinpoint the exact location of the fan blades at any given moment, creating a much more accurate 3D model.
Wow, so it's like adding another layer of perception, revealing details that would otherwise be invisible.
And what about transparent objects? How does sound help with that?
Well, transparent objects are difficult to detect visually because they don't reflect light in the same way as opaque objects, but they still interact with sound waves. By analyzing how sound reflects off a surface, researchers can determine whether it's transparent or opaque.
So it's like using sound to feel the scene, just like a bat uses echolocation to navigate in the dark.
Yeah.
This is truly groundbreaking stuff. It seems like the possibilities for robot audition are practically endless.
Indeed. This technology has incredible potential. Imagine a robot that can navigate safely through a glass door or even detect a thin sheet of ice on the road, all thanks to its ability to hear its surroundings.
Yeah, it really is amazing to think about robots actually using sound to enhance their vision in a way.
It really does. It challenges how we typically think about how senses work and how they interact.
Exactly. It's like we're breaking down the traditional boundaries between senses,
Yeah.
and we're showing that they can work together in ways that we never even thought possible before.
You mentioned that this technology is still in its early stages, but I'm curious, what are some of the specific ways researchers are using audio to improve visual scene reconstruction?
One fascinating area is using sound to help robots better understand how objects move. So imagine a robot that's trying to navigate a really busy warehouse where there are forklifts and people moving around constantly.
That sounds chaotic, especially if it's relying solely on vision, which could be obstructed or distorted by all that movement.
Precisely. But by incorporating sound, the robot can gain a much clearer understanding of the dynamics of that scene. For example, the whirring of a forklift motor or the footsteps of a person can give those valuable cues about their location and trajectory, even if they're partially hidden from view.
So the robot's using sound to predict where things are going to be rather than they're just reacting to where they are at that moment.
Yeah, that's a great way to put it. And this predictive capability is crucial for robots to operate safely and efficiently in these complex environments. Another interesting application is using sound to detect the material properties of objects.
Oh, that's interesting. Tell me how that works.
Okay, so let's say a robot needs to pick up a delicate glass object. If it relies only on vision, it might misjudge the amount of force that's needed and accidentally break the object.
That would be a costly mistake. But how can sound help prevent that?
Well, by analyzing the sound the robot makes when it comes into contact with the object, it can actually determine the object's material properties, like its hardness and its elasticity. This allows the robot to adjust its grip strength accordingly, making sure it can grasp the object safely and successfully.
So it's like giving the robot a sense of touch, but through sound.
Yeah.
That's amazing. So essentially, Robot Audition is helping robots perceive the world in a much richer and more nuanced way than they ever could with just vision alone.
Exactly. And this enhanced perception is opening up a whole new realm of possibilities for what robots can do. I mean, everything from performing delicate surgical procedures to exploring hazardous environments to providing companionship and assistance to the elderly. The applications are truly limitless.
It really is amazing to think about how far Robot Audition has come and how much potential it still holds. As we continue to blur the lines between the physical and digital worlds, it's clear that sound will play an even more important role in shaping our future.
I completely agree. And to our listeners, we encourage you to keep your ears open to the incredible advancements happening in the world of robot audition. You might be surprised at how this technology is already impacting your life and how it will continue to shape the world around us in the years to come.
It's been a fascinating journey exploring the world of Robot Audition with you today. Thanks for sharing your expertise and insights.
It's been my pleasure.
And to all our listeners, thanks for joining us on this deep dive into the world of sound and robotics. We hope you've enjoyed